What if the universe doesn't speak in words? What if it speaks in moments brief, fleeting, barely noticeable, and the only way to hear it is to pause, to listen, to notice? In the vastness of space, stars burn quietly. Galaxies spin slowly, their arms tracing silent patterns across the dark sky. The blackness between them is not empty, but full of distant fragments, moving, traveling, existing without being seen. Some of these fragments will pass through our solar system, unnoticed, until one is caught by our instruments, pulled from the quiet into the realm of our awareness. Such moments are brief. They last only a while before they are gone again. But in that time, they offer us a glimpse of something larger, something beyond our own world, our own sense of time, something that reminds us we are not the only motion in the universe, not the only story unfolding. 3IATLAS is one such moment. It came from far beyond, a visitor from the unknown. When we first noticed it, we named it, measured it, analyzed it. Yet even as we studied it, we knew that there was more than just the facts. There was the question itself. The question was not about where it came from, or what it was made of, or even why it passed through our system. The question was about what it means to notice at all. When something moves across the sky, what does it mean to witness it? We see the stars, we see the planets, we see the moon, and we know they are always there. But when something unfamiliar appears, a comet, a fragment, a wandering object, it captures our attention. It forces us to look up, to reflect, to wonder. Perhaps the message of such visitors is not in what they carry, but in the act of noticing them, in the way their appearance makes us pause, makes us question, makes us look up. In this way, the universe speaks not in clear messages, but in hints. A small object passes by, and in that passing, we are reminded of the vastness, of the time it took to reach us, and of the quiet journeys that fill the space between stars. The visitor says nothing in words, yet in its presence, we are forced to reckon with the silent movement of the universe. We are reminded that we are part of something much larger, much older, and much slower than we could ever imagine. Perhaps this is why the universe remains so quiet. It speaks not in noise, not in blaring signals, not in words we can understand. It speaks in the patterns we see, in the objects we notice, in the moments that shift our perspective. It speaks in the spaces between the stars, the pauses in the rhythms of galaxies, the silences between the answers we think we have. Still, we long for more. We long for a message. We long for answers. We long for some kind of communication that will tell us why we are here, why we are searching, why we look up. But the universe does not offer answers in the way we expect. It offers glimpses, moments, fragments of understanding that we must piece together ourselves. The question is never fully answered, because the answer is not the point. The point is in the searching. The point is in the noticing. The point is in the asking. In this way, the universe teaches us a kind of patience. It teaches us that meaning does not always come quickly. It teaches us that sometimes the silence is more meaningful than the words. It teaches us that the act of looking, of wondering, is itself a form of connection. We may not understand the visitor that passed through our sky. We may not ever know where it came from or where it is going. But in that moment of noticing, we are part of something larger. We are part of the universe, however small our part may be. And so, we continue to look. We continue to ask. We continue to listen for the faintest signals, the softest whispers of the cosmos. Perhaps 3IATLAS carried a message not in its form, not in its trajectory, not in its light, but in the way it made us stop and wonder. Perhaps its message was that we are not alone, not in the universe, and not in our search for meaning. What if the universe speaks not through noise, but through the quiet? What if it speaks not in words, but in moments, in fragments that pass by, in visitors that appear briefly and then are gone? What if the message is in the noticing, in the silence, in the pause between what we understand and what we still wonder? As we reflect on this, the sky continues to turn above us. The stars continue their quiet dance. The fragments continue to drift. And we too continue wondering, searching, noticing. What if 3IATLAS was not just a visitor, but a question that invited us to listen more closely, to wonder more deeply, and to remember that in the silence there is meaning. When we speak of interstellar objects, we are speaking of visitors from beyond. Not planets, not moons, not the familiar comets that loop around the sun, but fragments born elsewhere. They come to us by chance, passing through our solar system before fading back into the dark. To understand what 3IATLAS may be, we must first understand what such objects are and how they come to exist. Astronomers define an interstellar object as any body that is not bound to the sun by gravity. Ordinary comets and asteroids follow orbits that bring them back eventually, some after hundreds or even thousands of years. Interstellar objects are different. Their paths are open curves, hyperbolas, which means they arrive once and then are gone forever. This distinction may seem mathematical, but it carries deep meaning. It tells us that these bodies are true wanderers, not citizens of our solar system, but travelers passing through. The galaxy is filled with such travelers. Stars are not isolated. Around each star, planets form from disks of gas and dust. In those early times, collisions are constant. Fragments are scattered. Some crash inward, becoming part of growing worlds. Others are thrown outward with such speed that they escape their home star's gravity entirely. Once free, they wander interstellar space indefinitely, cold and silent, until gravity brings them near another star. Our sun is one of countless such attractors, and every so often, it captures our attention by letting one of these wanderers pass close enough to be seen. The discovery of 3IATLAS was not the first time humanity had glimpsed such a traveler. In 2017, astronomers detected Oumuamua, the first interstellar object we ever identified. It was unusual, elongated, spinning in a way that puzzled scientists. Then, in 2019, Comet Borisov appeared, more easily understood, showing the familiar coma and tail of a typical comet, but traveling on a hyperbolic path. And then, in 2023, Atlas joined the list as the third. 3 observations in less than a decade, after centuries of none, suggest that these visitors are not rare, they are common. Our instruments are only now sensitive enough to notice them. This changes how we see the galaxy. We no longer think of star systems as sealed. Instead, we see them as part of a constant exchange. Material flows outward. Some fragments may carry frozen water, organic molecules, or mineral dust. When they pass through another system, they bring with them the chemistry of their birthplaces. In this way, the galaxy becomes a shared space, where seeds of matter drift across unimaginable distances. From a strictly scientific view, there is nothing surprising about this. Planetary formation naturally produces debris. Gravity naturally scatters it. Time naturally spreads it thinly across the galaxy. Yet, when we consider 3IATLAS not only as a fragment but as a messenger, a different layer of meaning appears. If nature can send such travelers endlessly, could intelligence one day use the same process deliberately? Could civilizations scatter their own fragments across space, embedding intention within what looks like accident? It is a thought experiment more than a conclusion, but it shows how science and imagination intertwine. The physics of ejection is well understood. A planet in motion can sling smaller bodies outward. A near collision can provide the velocity needed to escape a star's grasp. These mechanisms are random, but they could also be harnessed. A civilization with advanced knowledge might guide debris instead of letting it scatter blindly. They might shape trajectories, send signals hidden in orbits, or even use natural bodies as carriers for technology. Even if such scenarios remain speculation, they connect to a deeper truth. Interstellar objects are reminders of time on a scale we rarely consider. 3IATLAS may have been traveling for millions of years before it arrived here. It may continue for millions more before it comes near another star. Its journey is long beyond our imagination, yet we saw it during our brief century of astronomy. The coincidence feels meaningful, though it may not be. It invites reflection on our own place in this flow of time. Astronomers study interstellar objects with care. They measure velocity, brightness, and spectra, gathering data before the visitor fades. Each observation expands our understanding of planetary systems beyond our own. We learn not only about one fragment, but about the processes that shaped countless others. Yet science does not erase wonder. The facts explain how such objects exist, but they do not silence the question of why we encounter them now, or what we choose to make of them. Still, the science itself has its own quiet beauty. Consider the orbital mechanics. The sun's gravity bends the path of 3 3IATLAS, but not enough to capture it. It curves inward, swings around, and continues outward, changed but free. The mathematics describes this perfectly, yet the motion remains graceful, like a visitor, bowing briefly before departing. In this, too, one can see the metaphor of a messenger, a short approach, a passing presence, a return to silence. The chemistry tells another story. When sunlight reflects off its surface, we infer the presence of dust and ice. When its brightness changes, we imagine jets of sublimating gas, faint and fleeting. These details connect it to comets, to frozen bodies that wander our own system. They make it familiar, yet still foreign. It is like hearing an accent, recognizable as speech, but carrying sounds from elsewhere. In this way, chemistry itself becomes a language, one that we can partly read, but never fully translate. Perhaps this is why interstellar objects feel significant beyond their scale. They are small, only a few hundred meters or kilometers across, yet they carry with them the weight of distance and time. They remind us that the galaxy is not empty, but alive with motion. They remind us that other systems have histories, and fragments of those histories drift into ours. They remind us that we are part of something far larger, even when the evidence is only a faint dot in the night sky. So, what is the science of interstellar objects? It is the study of fragments, of debris, of chance encounters between stars. It is the physics of orbits, the chemistry of ice, the patience of time. It is the careful observation of faint visitors that pass once and never again. And yet, beneath the precision, it is also an invitation to imagine. Because each object is both fact and metaphor. It is both rock and symbol. It is both ordinary and extraordinary, depending on how we choose to see it. In the end, 3IATLAS may be nothing more than what science says it is. A piece of debris ejected long ago, wandering through the galaxy until it passed through our system. But the calm truth does not erase the quiet question. What if it was more? What if, in the long silence of space, such objects are the closest thing we will ever have to messages? Perhaps they are not messages sent, but messages received, created in the act of noticing. And so, we pause with that thought. Science provides clarity. Imagination provides depth. Between them lies the space where wonder rests. 3IATLAS is gone now, but the reflection it left behind remains. It tells us that the galaxy is vast, full of travelers, full of stories carried in silence. Whether or not we call them messengers, they remind us of our place in the endless exchange of the stars. When we try to understand distant objects, we often begin not with touch but with light. Light is the messenger that reaches us across millions of kilometers, carrying information about what we cannot approach. For interstellar objects like 3IATLAS, light is almost all we have. We cannot fly there. We cannot sample its surface. We only measure how it reflects the sun, and how that reflection changes as it moves. Astronomers call this pattern of brightness a light curve. A light curve is simple in appearance, a graph that shows how much light is received over time, but hidden within its slow rise and fall are details about the object's shape, its rotation, and sometimes even its surface composition. Light curves are like shadows. They are indirect, partial, and easy to misinterpret, but they are the first clues we receive. For 3IATLAS, its light curve was faint, almost at the limit of detection. Its brightness shifted subtly, suggesting that it was not a perfect sphere but irregular, perhaps elongated or tumbling as it traveled. Small changes in brightness told of uneven surfaces, edges catching sunlight at different angles, patches of ice or dust reflecting in uneven ways. These fluctuations do not give us a picture, but they give us rhythm, the slow turning of a body in the dark. We have learned much about asteroids and comets this way. Some spin quickly, others slowly. Some wobble in a state of tumbling rotation. The light curve becomes a kind of fingerprint, revealing patterns invisible to the eye. For interstellar objects, these fingerprints are precious. We will never see them up close. We will never send a spacecraft to catch them as they race away. Light is all that remains once they fade. But light curves also carry uncertainty. For Oumuamua, the first interstellar object, its strange cigar-like or possibly pancake-like shape was inferred from extreme variations in brightness. Yet no single model fit perfectly. Scientists debated. Was it elongated like a needle or flat like a disc? Was its surface smooth or fragmented? With only a faint curve, conclusions remain unsettled. For 3IATLAS, the same is true. The faintness of its signal leaves room for many interpretations. This uncertainty opens the door to imagination. What if brightness changes are not only about shape, but about design? If an object were created by intelligence, its surface might reflect light in deliberate ways. Brightness could pulse in patterns, a silent signal encoded in rotation. Even without radio transmissions, light itself could be language. We have no evidence of this. For 3IATLAS, the patterns seem consistent with natural causes. Still, the thought lingers. Could shadows themselves carry intention? The idea is gentle, not urgent. It does not claim discovery. It only asks us to notice the possibility. If we imagine 3IATLAS as a messenger, then its faint shifting light might be its script. A script we cannot read, but one that leaves us aware of its presence. In this sense, the light curve becomes more than data. It becomes poetry, written in brightness and silence. Scientists remain cautious. They use models, compare possibilities, and publish results with care. The consensus is that 3IATLAS is an irregular, natural body. Its light behaves as expected for a comet-like fragment. Yet even scientists acknowledge the limits of certainty. With objects so faint and fleeting, what we know is only an approximation. Beyond the numbers lies a wide horizon of what we do not know. Still, the scientific value is immense. By studying light curves, we refine our ability to detect small, fast-moving objects. We prepare for the future, when surveys like the Vera Rubin Observatory will find many more interstellar travelers. Each one will bring new patterns of brightness, new shadows across our graphs, new opportunities to learn. 3IATLAS is not the last. It is only one in a long series we will one day witness. And yet, beyond the science, the philosophical reflection remains. Light is the oldest messenger in the universe. Stars shine, and their light tells us of their birth, their age, their eventual death. Planets reflect that light, and in the reflection we see hints of atmospheres and surfaces. Dust scatters it, comets glow with it, galaxies carry it across billions of years. All of astronomy rests on light. To see 3IATLAS through light is to join a long tradition, to listen to the quiet voice of the cosmos, spoken not in sound, but in illumination. Perhaps the shadows we record are not accidental. Perhaps they remind us that knowledge is always partial. No matter how precise our instruments, we never hold the whole picture. We see brightness rise and fall and rise again, but we never see the object itself. In this way, science mirrors philosophy. Both accept that what we know is only a shadow of what exists. So we return to the question, what if 3IATLAS was a messenger? Maybe its message was nothing more than the flicker of its light on our telescopes. A reminder that even faint signals from the void can carry meaning. A reminder that light, though simple, can connect us to places unimaginably far away. A reminder that shadows, though incomplete, can guide us toward understanding. And as we close this reflection, we let the image settle, a small fragment turning slowly in space, sunlight brushing its surface, brightness rising and falling like a calm heartbeat. A traveler casting shadows across our instruments, and in those shadows, leaving us not answers, but questions. When sunlight reflects from a distant body, it does more than create a light curve. It carries information about the substance of the object itself. Through spectroscopy, the study of how light is absorbed and emitted, astronomers can separate light into colors, or wavelengths, and from those patterns, they learn what elements and molecules are present. For an interstellar object like 3IATLAS, spectroscopy is our only way to glimpse its chemistry, to know what it is made of without ever touching it. Comets within our solar system are rich in water ice, carbon compounds, silicates, and dust. As they approach the sun, heat causes ices to sublimate, forming tails of vapor and fine grains. These emissions leave signatures in the spectrum. By comparing patterns of absorption and emission, scientists can identify water, carbon dioxide, ammonia, and even organic molecules. When astronomers turned their instruments toward 3IATLAS, they looked for the same clues. The signals were faint, but familiar. Its chemistry resembled that of comets we know. frozen volatiles warmed by sunlight, dust scattering light, subtle traces of carbon-based compounds. Nothing in its spectrum demanded a new category. In a sense, this was comforting. It meant that our solar system is not unique. The materials that formed Earth and its neighbors also exist elsewhere. Water, carbon, and dust are not local accidents. They are galactic ingredients, repeated from star to star. Yet, even within familiarity, mystery remains. For objects so faint, the data is sparse. Spectra may confirm certain compounds, but leave others uncertain. Small differences may be hidden by distance, by noise, or by the brief window of observation. In this uncertainty lies room for imagination. If 3IATLAS carried something unusual, a rare element, a compound unknown to us, it might escape detection. What we see is partial, what we miss could be vast, and so speculation begins. Could an advanced civilization choose materials not for chance, but for purpose? If one wished to send a fragment across light years, perhaps one would select a composition that survives the journey. Ordinary ice evaporates quickly in sunlight. Certain alloys, certain crystalline structures, might endure longer. Even a trace addition of metals could change the way light reflects, altering the spectrum in subtle ways. If such choices were made, they would be nearly invisible to us. We would see an ordinary comet, but hidden within could be intention. This does not mean we have evidence of such design. The chemistry of 3IATLAS fits natural expectations, but the possibility opens a window of thought. The very fact that chemistry can be read across billions of kilometers suggests a form of communication. Nature communicates through spectra. Each line of color tells a story of atoms and bonds. Perhaps intelligence could communicate the same way, using chemistry as a language that transcends distance. In fact, this is how we ourselves search for life. When astronomers study exoplanets, they look for oxygen, methane, or water in their atmospheres. These are chemical signatures of processes that may include biology. We treat chemistry as message. If we see it that way for distant planets, why not for fragments like 3IATLAS? Even without deliberate intention, its composition is a kind of statement. Here is what exists in the place I came from. This thought carries a gentle weight. If comets like 3IATLAS travel between stars, then chemistry itself travels between stars. Water and carbon may drift across the galaxy, seeding systems with the materials for life. The delivery may be random, but the effect is profound. It suggests that life is not confined to one world. The ingredients are scattered widely, waiting for the right conditions. In this way, even a fragment of ice and dust becomes a messenger, carrying the possibility of life across time and space. Still, science remains grounded. Astronomers record spectra, compare them to models, and write careful papers. The conclusions emphasize what is known and acknowledge what is not. They remind us that faint signals can mislead. They note that chemical fingerprints can be ambiguous. This restraint is part of the scientific method, but it does not cancel the quiet wonder that accompanies the data. Perhaps this balance is the essence of studying interstellar objects. On one side, chemistry gives us knowledge. On the other, it gives us imagination. To know that carbon and water exist elsewhere is to feel connected. To wonder whether other compounds are hidden is to feel curiosity. Knowledge and imagination walk together, neither complete without the other. So we pause with a reflection. What if the chemistry of 3IATLAS is its message? Not words, not symbols, but elements arranged in silence. Hydrogen, oxygen, carbon, the simple building blocks of life, written into its body. A message that says, the galaxy shares its ingredients. A message that reminds us that what we find familiar on Earth is not limited to Earth. A message carried not in intention, but in existence. In this way, the unknown becomes a form of teaching. The faint lines of its spectrum do not give us certainty. They give us humility. They remind us that we see only a fraction of what is real. They remind us that the universe is not constructed for our understanding, but we may glimpse enough to wonder, and in that wondering, we find rest. As 3IATLAS drifts farther from the sun, its chemistry fades beyond detection. The gases disperse, the light weakens, and the record closes. What remains is not the object itself, but the memory of its spectrum, the lines of color inscribed in instruments and in thought. From those lines, we carry forward both knowledge and mystery. And so, once more, we return to the question, what if 3IATLAS was a messenger? If so, perhaps it spoke not with signals, not with machines, but with atoms. Atoms arranged long ago, scattered into space, drifting until they reached us. A message of common elements, reminding us that we belong to the same galaxy, shaped by the same matter, moving through the same silence. Throughout human history, comets and wandering stars have never been seen as ordinary. Long before telescopes, people noticed bright trails across the night sky. These sudden appearances inspired awe, fear, and speculation. To ancient cultures, a comet was never just a natural event. It was a sign, an omen, a message written in the heavens. The Babylonians recorded comets as portents of war or famine. The Chinese kept careful astronomical logs, treating each appearance as a symbol of change. In Europe, comets were seen as divine warnings, sometimes heralds of the death of kings. Even into the modern era, the sight of a blazing comet tail in the sky carried weight far beyond astronomy. To look up and see such a visitor was to feel the presence of something greater, something beyond human control. Today, science explains comets in physical terms. They are icy remnants from the early solar system, orbiting the sun in long, stretched paths. When heat causes their ices to sublimate, they release gas and dust, creating glowing comas and tails. No longer omens, they are studied as natural archives of planetary formation. Their chemistry tells us about the conditions of the early solar nebula. Their dust carries organic molecules that may have helped seed Earth with the ingredients for life. And yet, the symbolic layer never fully disappears. Even when described by physics, comets remain evocative. They arrive suddenly, move across the sky, and then vanish. They appear to carry meaning simply by their presence. This duality, both scientific and symbolic, reflects the way we also approach interstellar objects like 3IATLAS. On one side, they are natural fragments. On the other, they feel like messengers. The idea that comets could deliver more than symbolism is not new. In the 19th century, some scientists speculated that life might spread through space on comets, a concept called panspermia. Microbes or organic compounds, shielded within icy bodies, could survive interstellar travel and seed new worlds when they land. In this view, comets are carriers of possibility, not only in myth but in biology. Modern research has shown that amino acids and complex organic molecules exist in comets. They are not alive, but they are part of the recipe for life. Their delivery across time and space strengthens the idea that messengers can be real, even if unintentional. If local comets can play this role, what about interstellar ones? 3. Atlas may have traveled millions of years from another system. In that time, it could have carried frozen compounds, dust, or even the building blocks of biology. If such fragments pass between stars regularly, then chemistry is exchanged on galactic scales. The galaxy itself becomes a network of delivery, each comet a small courier of matter. Whether or not it is deliberate, it is still a form of message, the message of connection. This thought softens the boundary between science and imagination. On one hand, panspermia is a hypothesis, debated and unproven. On the other hand, it aligns with what we know. Life on Earth required certain ingredients, and those ingredients are found in comets. To wonder if interstellar comets carry the same role is a natural step. Perhaps 3IATLAS, like comets before it, is part of this ancient process, scattering seeds across the stars. But what if we imagine a step further? What if, long ago, another intelligence recognized the same possibility? A civilization aware of chemistry, aware of biology, might have looked at comets not only as natural objects, but as tools. They might have chosen to guide them, to send them outward, carrying either biology itself or messages hidden in matter. To us, such actions would be indistinguishable from chance. A drifting comet and a guided one would look the same from a distance. Yet, in thought, the question lingers. How do we know the difference between accident and design when both follow the same physics? Even without design, the symbolic weight remains. 3IATLAS, like comets before it, appeared briefly and then was gone. Its very transience evokes meaning. It reminds us of the shortness of human attention compared to cosmic time. It reminds us that the universe offers signs not by intention, but by motion. We interpret them, as our ancestors did, because interpretation is part of being human. From this perspective, comets and interstellar visitors are ancient messengers in two ways. They are ancient in age, drifting for millions of years, and they are ancient in meaning, for humanity has always looked upward and asked what such lights signify. Whether as omens, as seeds of life, or as cosmic debris, they carry messages shaped by our response. The science continues calmly. Astronomers measure orbits, spectra, and tails. They catalogue data, building models of how comets form and evolve. These studies are precise, careful, and cumulative. Each comet observed refines our knowledge of planetary systems. Each measurement contributes to understanding. Yet beyond the numbers, the symbolic echo endures. Perhaps this dual nature is itself the message. Comets are both natural and meaningful. They are both physical bodies and cultural symbols. They show us that science and imagination are not opposed, but layered. To see a comet is to learn about chemistry. To interpret a comet is to reflect on ourselves. The same is true for 3IATLAS. Its science and its symbolism coexist, neither cancelling the other. And so, once more, we circle back to the question: what if 3IATLAS was a messenger? If so, perhaps it was not a new kind of messenger, but a continuation of an ancient tradition. For thousands of years, humanity has seen wanderers of rock and ice as signs. Today, with telescopes and equations, we see them differently, yet still we ask the same questions. We wonder what they mean, what they carry, and why they come when they do. In the end, 3IATLAS may be only a fragment, silent and indifferent. But in our response, it becomes more. It becomes part of a long history of looking upward and finding meaning in the fleeting. It joins the lineage of comets as messengers, not because of what they truly are, but because of how we choose to see them. And in that choice, we find continuity. Across cultures, across centuries, across the gap between myth and science, the same reflection emerges. The universe speaks, even in silence. It speaks through fragments of rock and ice, through brief appearances in the night sky, through objects like 3IATLAS. Whether intentional or not, the message is received, and in receiving it, we are reminded of our place in the vast exchange of time and stars. Every object that moves through space carries a path. That path is written not in ink, but in gravity. For planets, moons, and comets, gravity ties them to the sun in orbits that repeat. For interstellar objects like 3IATLAS, gravity shapes their course but cannot hold them. Their trajectories are hyperbolic, open and fleeting, a whisper of presence that passes once and then fades. To understand 3IATLAS, astronomers studied its orbit carefully. They measured its speed as it entered the solar system, the way sunlight bent its path, and the curve it followed as it left. The numbers revealed that it was moving too quickly to be bound. The sun's gravity slowed it, but not enough to capture it. It came in, turned gently, and continued outward, on its way to the distant dark. This is what makes interstellar objects so distinct. Unlike comets that return after centuries, they are visitors who appear only once. Their orbits tell us they are not of this system. They belong to somewhere else, though we cannot say exactly where. Their origins are whispered in the angle of approach, in the speed they carry, in the faint bend of their path as they slip past the sun. For 3IATLAS, the orbit spoke of an unusual entry. It did not come from the familiar plane where most of our planets move. Instead, it approached at an angle, as if drawn from a different layer of the galaxy's architecture. This angle sets it apart, reminding us that the galaxy is not neatly ordered. Some objects move with the flow of stars, others cross it, their histories untidy, their trajectories old and uncorrected. Orbital analysis also showed that 3IATLAS had likely been traveling for millions of years. To drift from another star system to ours requires time beyond human imagination. During that journey, it would have passed through silent regions of interstellar space, where stars are far apart and gravity is weak. Its motion was steady, shaped only by the memory of the ejection that set it free long ago. And yet, when it came near the sun, its path bent. Gravity touched it, altering its direction just slightly. The curve was shallow, but enough to show us that it was here, enough to mark its visit in our instruments. Then, as quickly as it came, it was gone again. The orbit we traced was not just a line in space, but a reminder of how transient our contact truly was. Still, orbits can invite speculation. The exact angle, the precise speed, the timing of its arrival, all are open to interpretation. Could such a path be intentional? Could a trajectory be chosen, nudged, or guided to bring an object close enough to be noticed? Physics allows both chance and choice. A rock can be flung randomly by planetary motion, but the same physics could be used deliberately by intelligence. We cannot know which it was. We can only see the path and wonder. Astronomers remain cautious. They describe the orbit as natural, the product of ejection from another system and capture by our sun's gravity. The mathematics works. No anomalies demand another explanation. And yet, for those who ask, what if, the orbit leaves room for thought. A messenger might not announce itself with signals. It might simply arrive on a path that brings it within sight, and then continue on. Presence itself becomes the message. In this way, the orbit is both scientific and symbolic. Scientifically, it tells us about velocity, angle, and distance. Symbolically, it tells us about transience. The curve of 3IATLAS across our sky is like a line written briefly and then erased. It speaks of encounters that do not last, of meetings that leave memory but no permanence. This reflection extends beyond astronomy. In human life too, paths cross briefly. People meet, connect, and move on, leaving traces in memory but not in permanence. The orbit of 3IATLAS becomes a metaphor for all such crossings. It reminds us that not every meeting is meant to endure. Some are meant only to remind us of connection before drifting apart. From a broader perspective, orbits remind us of humility. The sun bends trajectories, but even the sun cannot hold everything. Some things pass through beyond its reach. In this, we see that even the most powerful centers have limits. Gravity shapes, but it does not control all. The universe allows openness, movement, and freedom. And so, once more, we return to the central question. What if 3IATLAS was a messenger? If so, perhaps its message was carried not in composition, not in brightness, but in its path itself. A whisper of motion, saying, not everything belongs to one place. Not everything can be held. The galaxy is wider than ownership, older than control. Some things exist only to pass by, and in passing, remind us of the vastness that surrounds us. The orbit of 3IATLAS has been calculated, archived, and will be remembered in charts and data tables. But beyond numbers, it remains a quiet gesture. A line drawn once, never to be drawn again. A path that bent just enough for us to see, and then continued outward, into silence. In that silence, we are left with reflection. Orbits speak, even when they whisper. They tell us of gravity, of motion, of time. They tell us of what can be held and what cannot. They remind us that even fleeting visitors leave impressions, if only in thought. Perhaps this is the essence of orbital whispers, that paths themselves can carry meaning, that a curve across the sky can be a form of communication, that even in the absence of words, the geometry of motion can remind us of our place in the universe. Every journey through space is marked not only by a path, but also by a speed. The speed of an object tells us how it moves, what forces act upon it, and what history it carries. For interstellar travelers like 3IATLAS, speed becomes one of the clearest signs of their origin. It is the key that tells us they do not belong here. When astronomers measured the velocity of 3IATLAS, they found it was faster than anything the sun could hold. Ordinary comets and asteroids move in predictable ranges, bound by gravity. Even those that travel far into the Oort cloud remain tied to the sun's pull. But 3IATLAS entered with a velocity already beyond escape. This meant that, long before it came near us, it was already free. It was not captured, and it could not be slowed enough to stay. Its speed was tens of kilometers per second, steady and precise, far higher than the speeds of typical solar system bodies. To us, such numbers are difficult to imagine. At that pace, it could cross the distance between Earth and the Moon in only a few hours. Yet in cosmic terms, this is still gentle, unhurried motion. Space is vast, and even great speeds unfold across enormous distances slowly. Still, compared to the familiar motions of planets, this velocity set 3I/ATLAS apart. Speed carries memory. An interstellar object does not move quickly by accident. Its velocity is the result of past encounters, of gravitational slingshots near massive planets, or the violent scattering of early planetary systems. Long ago, 3I/ATLAS must have been pushed outward by some event, given enough energy to leave its home star forever. That energy is still visible in its motion today. It carries the fingerprint of its origin in the pace of its travel. This gives speed a second meaning: permanence. Once free of a star, an object continues nearly unchanged, slowed only slightly by the weak pull of the galaxy itself. Millions of years pass, and the speed remains. In this way, 3I/ATLAS is both ancient and immediate. Its motion today is a trace of an event that may have happened before humans existed, before Earth's civilizations began, perhaps even before Earth itself was formed as it is now. And yet, as with orbit, speed invites speculation. If 3I/ATLAS were natural, its velocity is explained by scattering. But if it were something else, what then? Could an intelligence choose a speed with care, sending an object not just anywhere, but here? Could velocity itself be a message, a deliberate sign of control? We cannot say. The data is consistent with natural causes. Still, the thought lingers. What if the speed is more than chance? From a symbolic view, the velocity of 3I/ATLAS reminds us of transience. Its passage was swift. In a matter of weeks, it moved from discovery to fading beyond detection. We saw it only briefly, and then it was gone. Its speed carried it past us before we could fully study it. In this, it feels like a messenger who does not stop to speak, but only passes by, leaving questions behind. Astronomers tried to gather as much data as possible in the short time available. Telescopes tracked its motion, measured its light, calculated its trajectory. But the speed limited what we could learn. Unlike comets that linger for months, interstellar objects give us only fleeting opportunities. We must accept that some mysteries remain unanswered, carried away by velocity beyond our reach. Still, speed has beauty. To imagine a fragment drifting across the galaxy for millions of years at steady pace is to imagine endurance. 3I/ATLAS is not hurried. Its speed is great to us, but gentle compared to the scales of the galaxy. It moves with patience, covering distances that seem infinite, unbothered by time. In this, speed becomes not urgency, but calm persistence. It is motion without rest, but also without haste. Perhaps this is part of its message. What if 3I/ATLAS reminds us that journeys need not be rushed, even when they are swift by our standards? What if speed itself can be seen, not as urgency, but as inevitability? It continues forward, because that is what it must do. It carries no destination, only direction. In this, its velocity becomes a lesson. Progress is not always about arrival, but about movement itself. The scientific side remains clear. Its speed marks it as interstellar. Its velocity confirms it cannot return. Its motion tells us about the processes that formed it long ago. These are steady conclusions, supported by evidence. But beyond them, reflection arises naturally. The swiftness of its visit reminds us of the brevity of opportunities, the importance of noticing, the humility of being unable to hold on. Perhaps the truest message of speed is impermanence. What comes quickly may leave quickly. What passes through may never return. Yet even in impermanence there is meaning. To witness, even briefly, is to be changed. To measure, even imperfectly, is to be connected. To reflect, even in passing, is to feel the vastness of what lies beyond. And so we return to the question once again. What if 3I/ATLAS was a messenger? If so, its message may have been carried not in signals, not in words, but in velocity, a pace beyond our familiar scales, reminding us that we are part of a larger motion, one that flows across the galaxy. A reminder that even what passes quickly can leave lasting thoughts. A reminder that in speed, as in silence, meaning may be found. In the end, the numbers are precise. Tens of kilometers per second, a hyperbolic trajectory, a passage that will not repeat. These are the facts. But wrapped within them is something quieter, a reflection on transience, endurance, and the endless journey of matter through space. 3IATLAS moves on, but the impression remains, written not in its body, but in our awareness. What if 3IATLAS was a messenger, yet it spoke in silence? The universe is not a quiet place. Stars pulse, galaxies collide, black holes release bursts of energy across the spectrum, and still, for all this activity, space can feel empty. It can feel still. The silence between the stars is vast. Into that silence, 3IATLAS drifted, carrying only the faintest reflection of sunlight. When astronomers first noticed its motion, they turned their instruments toward it quickly. They measured its orbit, they studied its light curve, and they listened. For decades, the idea of listening for signals from beyond Earth has been part of the scientific imagination. Radio telescopes have scanned the skies, waiting for a narrowband signal, a steady beacon, or a repeating pattern that could not be explained by natural causes. It is a quiet search. It is a patient one. With 3IATLAS, radio antennas were tuned carefully. Observations were made at multiple frequencies, in the hope that a signal might emerge. The expectation was modest. Still, there was a quiet possibility. If this object was a natural comet, its only message would be the soft hiss of gas leaving its surface. If it was something else, perhaps there might be more. The data came back without clear anomalies. No narrowband signals, no repeating pulses, no clear patterns beyond the noise. The scientific conclusion was straightforward. 3IATLAS is silent. It does not broadcast. It does not announce itself. It moves quietly, like a fragment of ice and dust should. Yet silence is not absence. Silence is also a form of presence. In human experience, silence is not emptiness, but a space that holds potential. In conversation, silence can mean hesitation, or reflection, or a waiting breath. In music, silence gives shape to sound. In meditation, silence itself becomes a teacher. In this way, the silence of 3IATLAS may also carry meaning, even if unintended. We may ask, what if silence is the message? If an intelligence wished to communicate across the galaxy, it might know that radio signals are fragile, fading into background noise. It might know that light is scattered, absorbed, lost in distance, but silence endures. A silent visitor, arriving suddenly and leaving again, ensures that the message is not words, but presence. A message that says, we exist, but we will not disturb. We are here, and then we are gone. From the perspective of science, such thoughts are not necessary. Data is measured, analyzed, and compared. The silence of 3IATLAS matches expectation. A faint, icy body would not be expected to emit radio waves. Its silence is natural. The absence of a signal is the absence of evidence. The work of astronomy moves forward, precise, careful, grounded. Still, imagination lingers. Silence invites us to listen more closely. The quiet space in the data makes us wonder if we are missing something. Perhaps the signal was there, but in a form we cannot decode. Perhaps it is not radio at all. Perhaps it is written in patterns of reflection, or in the chemistry of the object itself, or in the very choice of its orbit. The silence becomes a surface onto which we project meaning. Consider how often humanity has faced silence before. The night sky is filled with light, yet it is silent. Stars burn for billions of years, but they do not speak in human voices. The silence itself has shaped our sense of the cosmos. It has led us to wonder, to measure, to build instruments that can extend our senses. It has taught us patience. It has reminded us that not all questions are answered quickly. 3IATLAS was silent as it passed. Its motion made no sound. Its light curve offered no words. Its chemistry gave only faint hints. Yet the silence did not end the conversation. It deepened it. In the absence of clear signals, we asked more questions. Could there be hidden meanings in the data we cannot yet read? Could the silence itself be the most universal form of communication? A way of saying, we are here, but we will not intrude. Perhaps the most gentle message is one without words. A reminder that the universe does not need to speak in order to be heard. A reminder that we, as listeners, create meaning in the spaces between signals. a reminder that silence itself can be a form of contact, as soft and steady as the dark sky above. In the end, the scientific record is simple. No signals were detected, the visitor passed in silence. The instruments recorded only faint light, fading with distance. Yet the reflection remains. The silence itself becomes part of the story. It becomes part of our awareness. And so we return to the question once more. What if 3IATLAS was a messenger? If it was, perhaps it did not speak in sound or light. Perhaps its message was silence, offered across the void. A message that we are not alone, and yet we are free. A message that presence does not require words. A message that what we notice, even in quietness, can change how we see the universe. As we rest with this thought, we feel the calm rhythm of silence itself. Not an emptiness, but a gentle space. A pause that allows the mind to slow, the breath to soften, and the night to stretch endlessly. In this silence, 3IATLAS still drifts, still moves, still whispers without words, and we, listening, are reminded of the quiet vastness that surrounds us. When astronomers look into the sky, they rarely see objects in detail. At interstellar distances, even large bodies appear only as points of light. The stars are dots, the comets are blurs, and yet, by tracing the way light changes over time, scientists can begin to imagine the shapes that hide behind the brightness. The shape of an object, though unseen, leaves a shadow in the data. For 3IATLAS, this shadow was faint, but it was not uniform. The brightness of the object shifted gently, rising and falling in a repeating rhythm. That rhythm told a story. It suggested that the body was not a perfect sphere. Instead, it was irregular. Perhaps it was elongated, stretched like a needle, or perhaps it was flattened, shaped more like a disc. The details are uncertain, but the implication is clear. This was not a simple, rounded rock. It was something stranger. In our own solar system, comets are often irregular. They have been battered by collisions. Their surfaces are scarred by impacts, fractured by heat, and reshaped by outgassing. Many resemble potatoes or lumpy fragments, rotating slowly, reflecting sunlight unevenly. When viewed from Earth, their brightness rises and falls as they turn, showing one surface and then another. The same reasoning was applied to 3IATLAS. The changes in its light curve could be explained by its shape. Perhaps it was long and thin. Perhaps it was flat and wide. The data did not settle the matter. Models could fit either possibility. This uncertainty is common in astronomy, where distance hides detail. We know only what light allows us to know. Yet even in this uncertainty, questions emerge. An elongated shape is unusual. Most asteroids are irregular, but not extremely stretched. Most comets are rounder, more compact. Oumuamua, the first interstellar object we saw, also appeared elongated or flattened, with a ratio unlike anything we had seen before. Now, with 3IATLAS, a similar uncertainty appeared again. Could this repetition suggest a pattern? Could it mean that such unusual shapes are common in interstellar debris? Or could it mean something else? If we allow ourselves to imagine, another possibility arises. What if such shapes are not the product of chance? What if they are chosen? A long, thin body would experience less resistance as it moves through the thin gas and dust of interstellar space. A flat body could act like a sail, catching faint pressure from starlight and accelerating across the galaxy. These are not unreasonable ideas. They are grounded in physics. Light itself can push objects. A thin sheet could, in principle, be propelled by starlight. This speculation has been raised before. When Oumuamua was first studied, some scientists wondered if its shape and motion could be explained if it were a light sail, a thin, broad surface, built to capture radiation pressure. If so, it might have been a technological object, not a natural one. For 3IATLAS, the data do not confirm such an idea, but the resemblance invites the thought. Perhaps we are seeing more than one example of a family of objects shaped by forces we do not yet understand. Still, the scientific approach remains cautious. Natural processes can stretch or flatten objects. Tidal forces near stars can pull bodies apart, leaving fragments with elongated forms. Collisions can break larger bodies into shards. The galaxy is vast, and time is long. Unusual shapes may arise often, scattered among the stars. From this perspective, 3IATLAS is one example among many, not a deliberate construction. Yet the boundary between accident and design is thin. If a fragment can be elongated by chance, it can also be elongated by choice. If nature can make a shard, intelligence could also shape one. The question is not whether such shapes exist, but whether some might be used as tools. A light sail built by an ancient civilization might look much like an unusual rock. At interstellar distances, the two would be indistinguishable. In human history, shapes have always carried meaning. The circle, the square, the spiral, the cross. These are forms that speak to us even without words. A pattern carved in stone becomes a message across centuries. A monument, a carving, a line in the sand. Perhaps the shape of an interstellar object is not only a physical form, but also a kind of cosmic writing, a message not made for us, but visible to us when we choose to see. As 3IATLAS turned, its light rose and fell like a breath. To the astronomer, this was a signal of rotation. To the poet, it was a rhythm. To the dreamer, it was a whisper. Each perspective is different, yet each is valid. The data is the same. The meaning is what we bring to it. In this way, the study of shape is more than measurement. It is an encounter with ambiguity. The light curve does not settle into one answer. It allows multiple interpretations, each plausible, each incomplete. Science records the range of possibilities. Imagination explores the spaces between them. And in that space, wonder grows. We may ask again, what if 3IATLAS was a messenger? If so, perhaps its shape was not random. Perhaps it was chosen for endurance, for travel, for visibility. Perhaps it was chosen to be seen, but not understood. A shape that is unusual, a shape that resists easy categorization, a shape that lingers in thought long after the object is gone. We may never know if this is true. The data does not confirm design. It does not prove intention. Yet the question itself becomes part of the message. To wonder if a shape is natural or made is to see it differently. It is to pause, to reflect, to imagine. As the object fades, its light diminishes, and the rhythm of its turning disappears from our instruments. The shape remains unknown, but the impression remains. Like the memory of a shadow, we are left with graphs, with numbers, with models. We are also left with quiet reflections, with questions that cannot be answered. And so, we close this part of the journey with humility. Shapes can be measured, but not fully understood. They can be explained by physics, but they can also be read as symbols. The truth may lie beyond our reach. Still, the act of looking, of wondering, is itself meaningful. Perhaps that is the gentle message of 3IATLAS. That form itself can remind us of mystery, that an object need not speak to be heard, that even in silence, even in ambiguity, the universe invites us to reflect. What if 3IATLAS was a messenger? Perhaps it carried no words at all. Perhaps it carried only its shape, turning slowly in the light of our sun. A shape unlike those we know, a shape that resists easy classification, a shape that whispers of distance, of time, of possibility. In that whisper, in that pattern of light and shadow, we are reminded once again of our place beneath the stars. We see a fragment pass, and we wonder, we measure, we model, we publish, but we also dream. And in that dreaming, we are part of the message ourselves. What if 3IATLAS was not only a fragment of rock and ice, but something more? What if it was shaped, guided, or released with intention? This is the thought that brings us to a quiet idea, the idea of cosmic engineers. In the history of science, humanity has often wondered whether advanced civilizations might exist elsewhere. The Milky Way contains hundreds of billions of stars. Around many of them, planets orbit. Some of those planets may be rocky, some may hold water, some may even host life. And if life arises in more than one place, then intelligence may arise more than once. Civilizations may grow, discover, and create. With enough time, some of them might learn to shape the cosmos itself. The concept of a cosmic engineer is not about a single being, but about the possibility of a culture that understands physics deeply enough to guide matter on a galactic scale. Such a civilization would not need to send radio signals. It could work with gravity, light, and motion. It could design objects that appear natural, yet carry purpose. From a scientific perspective, this remains speculation. No evidence requires it. The natural explanation for 3IATLAS is strong. An icy body, ejected from its home system, wandering freely until chance brought it here. Still, the speculative view lingers. If intelligence exists elsewhere, if it is ancient, if it is advanced, then perhaps such visitors are not always accidents. Perhaps they are deliberate. Imagine a civilization millions of years older than ours. For them, the galaxy is not distant, but familiar. They understand the physics of gravity not only as theory, but as craft. They can shape orbits the way we shape roads. They can adjust the speed of fragments the way we adjust sails. For them, an interstellar messenger might not be a fragile signal. It might be a fragment of rock or ice, guided onto a path that ensures it will cross the skies of other worlds. Why choose such a method? We can only guess. One reason might be endurance. Radio signals fade, light scatters, but matter persists. A fragment of ice or stone can travel for millions of years, surviving the vacuum, crossing distances that signals may not bridge. A fragment is slow, but it is steady. It carries something physical, something that endures even when time is vast. Another reason might be subtlety. A radio signal announces presence loudly across space. It invites attention. It may also invite danger. A fragment, disguised as a comet, announces nothing. It drifts silently. It does not force attention. It waits for a civilization capable of noticing. It is a message hidden in plain sight, seen only when the time is right. And perhaps there is another layer. A fragment like 3IATLAS might carry material chosen with care, a pattern in its shape, a ratio in its dimensions, a composition that differs slightly from natural expectation. These details, almost invisible, could be a form of writing. They could be signals embedded in matter itself. To us, the differences may appear as irregularities in a light curve. To another intelligence, they may be clear, the same way that a stone carving looks to us like art, but to a passerby it may look like random scratches. Meaning depends on the eyes that see. Still, science does not claim this. The measurements of 3IATLAS suggest natural origins. Its spectrum shows water, dust, and faint carbon compounds. Its orbit is consistent with scattering. Its speed is high, but not impossible. The evidence does not require intelligence. The simplest explanation remains that it is natural, and yet, the speculative question remains. Could an advanced civilization have used natural fragments as tools? Could the galaxy itself be filled with disguised messengers? If so, then every interstellar visitor becomes part of a larger network. Each fragment might be a node in a galactic conversation, drifting across space, carrying matter, carrying shapes, carrying silence. To us, they are accidents. To others, perhaps they are signals. The difference is subtle, almost invisible. The same orbit that looks random to us could be purposeful to them. The same chemistry that seems ordinary could be chosen for meaning. This brings us to a gentle reflection. Our own civilization is young. We have only recently begun to send objects beyond the solar system. Spacecraft like Voyager and Pioneer now drift into the interstellar dark. They carry plaques and records, symbols etched in gold, music pressed into metal. We have already chosen to send messages hidden in matter. To another civilization, encountering one of our probes in a distant future, the object may seem like debris, or it may seem like a messenger. In this sense, 3IATLAS mirrors our own choices. We see it, we measure it, we call it natural, but perhaps to another intelligence, our own probes will appear just as ordinary, just as ambiguous. They may wonder, as we wonder, whether what they see is random or intentional. They may ask, in their own calm way, what if this is a message? The thought brings us back to humility. Science gives us tools to measure speed, shape, and chemistry. It gives us confidence in natural explanations. Yet it also shows us the limits of knowledge. With faint signals, with brief visits, with great distances, certainty is rare. Ambiguity remains. In that ambiguity, imagination takes root. And in that imagination, we find meaning. So what if 3IATLAS was a messenger? Perhaps it was designed, Perhaps it was guided. Perhaps its shape, its orbit, its speed, and its silence were all chosen. Or perhaps it was simply a fragment of ice and dust, ejected long ago, moving as physics demands. Both possibilities remain open. Both leave us with wonder. The universe is vast. Civilizations, if they exist, may choose many ways to speak. Some may broadcast, some may build, some may whisper through matter. We may not know which path 3IATLAS followed. Yet its presence reminds us that messages need not be clear to be meaningful. Sometimes the act of wondering, the act of listening, is itself the message. As we let this thought settle, we imagine the object once more, a fragment drifting at steady speed, shaped by forces we cannot fully know, passing across our sky. To us, it is faint and brief. To the galaxy, it is timeless. It moves on, silent, patient, enduring. Perhaps that is the voice of the cosmic engineers, not loud, not urgent, but calm, leaving space for reflection. And so, as the object fades into the dark, we are left with a gentle question, not one that demands an answer, but one that allows rest. What if 3IATLAS was a messenger? What if its message was not in sound or words, but in its very existence? A reminder that the universe is vast. A reminder that intelligence, whether human or alien, is only one thread in a larger tapestry. A reminder that even in silence, there is meaning. Part 11. Time as a carrier. What if 3IATLAS was a messenger that traveled not only through space, but also through time? In the vastness of the galaxy, distance and time are always connected. To cross light years requires not minutes, not hours, but millions of years. Every interstellar object is not simply a traveler through distance, it is also a traveler through deep time. Astronomers estimate that 3IATLAS may have been on its journey for countless ages. It could have been ejected from its home system long ago, perhaps when that system was still forming. A planet may have shifted, disturbing the orbits of smaller bodies. A collision may have shattered a larger world, scattering fragments outward. One fragment, caught in the right trajectory, could have left its star behind entirely. From that moment on, it was no longer bound. It became interstellar. In space, time stretches differently than it does on Earth. On our planet, a human life is measured in decades. A civilization may rise and fall in centuries, but in the galaxy, stars burn for billions of years. Fragments like 3IATLAS can wander for eons without change. Their surfaces may darken, their ices may sublimate, their shapes may erode, but still they persist. The surface of such an object records its passage. Cosmic rays strike it constantly. Micrometeoroids chip away at its edges. Atoms are sputtered into space. Over millions of years, a layer forms, a kind of skin, altered by exposure. To astronomers, this weathered surface is evidence of great age. It is a sign that what we are seeing has travelled far, and has done so for a very long time. Still, the precise length of that journey is hard to know. Calculations of trajectory can suggest directions, but not always origins. The galaxy is dynamic. Stars move, orbits shift, clusters drift apart. The path of 3IATLAS may trace back to a particular region, perhaps near a young star, perhaps near a disrupted system, but over millions of years, even small uncertainties grow large. What began as a narrow line becomes a wide cloud of possibilities. This uncertainty opens space for imagination. If we cannot know where it came from, then we are free to wonder. Perhaps it began in a system like ours, where planets formed and collided. Perhaps it once passed near a star older than the Sun, carrying traces of a world that no longer exists. Perhaps it is older still, a fragment from the earliest days of the galaxy, older than Earth, older than the mountains and oceans we know. The idea of time as a carrier stretches beyond science. In human experience, time carries memories, traditions, languages, and stories. It weathers stone, it erases names, it softens voices, yet it also preserves. Fossils remain, ancient texts survive. Light from distant stars, emitted long ago, still reaches our eyes tonight. Time erases, and time remembers. If 3IATLAS is a natural fragment, then time has shaped it quietly, slowly, without intention. But if it is a messenger, then perhaps time is part of its design. An ancient intelligence might have known that radio signals fade. They might have known that civilizations rise and fall. They might have chosen to send matter instead, trusting that a fragment could survive where signals cannot. In this way, time itself becomes part of the message. Imagine a civilization millions of years old, watching their world change. They might gather fragments, encode them with information, and send them outward. They would know that the journey would take millions of years. They would know they might not survive to see the result, and still, they might send them, not for themselves, but for whoever might one day look upward and notice. From a scientific perspective, such speculation is unnecessary. Natural processes explain the speed and age of 3IATLAS, yet the idea lingers. If time can carry fragments across the galaxy, then it can also carry messages. The difference is subtle. The same erosion, the same weathering, could be accident or intention. The same surface that appears natural to us could hide patterns invisible until the right moment. Perhaps the surface of 3IATLAS was once smoother. Perhaps it carried lines, or shapes, or structures that spoke clearly. Over millions of years, cosmic rays may have erased them. If so, then the message was carried, but it was also lost. The universe may have delivered it, but time may have dissolved it. In this sense, time is both a messenger and a destroyer. It carries, but it also erodes. Still, even eroded, the fragment retains meaning. Its age itself is a message. It reminds us that the universe is old, far older than we are. It reminds us that our own history, long as it feels, is brief compared to cosmic time. It invites us to place ourselves in a larger frame, to see our lives not as isolated, but as moments in a much longer story. When 3IATLAS passed through our skies, it brought with it the weight of ages. It had travelled longer than our species has existed. It had seen stars form and die, clusters disperse, galaxies shift in their endless dance. It carried that history silently, in its speed, in its orbit, in its weathered surface. We could not read it fully. We could not reconstruct its story, but we could sense the depth of time behind it. This raises a gentle question. What if the purpose of such a messenger is not to deliver detailed information, but to remind us of scale? What if its message is simply the passage of time itself? A fragment that drifts for millions of years, that arrives briefly, that leaves again, might embody patience. It might embody endurance. It might remind us that the universe moves at a pace far slower than our lives, and that our own urgency is only a moment within that flow. We may never know if 3IATLAS carried anything more than ice and dust. We may never know if it was shaped or guided. Yet we do know that it travelled far, and for long ages. That fact alone is enough to bring reflection. It tells us that the galaxy is not static. It tells us that time is not empty. It tells us that even the smallest fragment can carry the memory of epochs. As we rest with this thought, we imagine 3IATLAS still drifting. Perhaps it has left our solar system. Perhaps it moves now into the deep dark, beyond the sun's influence. It carries its speed, its shape, its silence. It carries the memory of time itself. And we, for a brief moment, shared part of its journey. What if 3IATLAS was a messenger? Perhaps its message was not meant to be read in detail. Perhaps its message was the simple reminder that the universe is vast, and that time is long, and that our place within it is both small and meaningful. And so, once again, we are left with a quiet sense of humility. A fragment passed us, ancient and silent. We measured its speed, we traced its orbit, we studied its light. We did not find a signal. We did not decode a message. But in its long journey, in its endurance, in its silence, it carried something deeper. It carried the reminder that we too are travelers through time. We move briefly, we shine briefly, and then we, like 3IATLAS, continue into silence. What if 3IATLAS was not only a solitary fragment, but a thread in a much larger fabric? To imagine this, we need to step back. We need to look not only at the orbit it traced around our sun, but at the wider stage on which it was moving. That stage is the Milky Way, a galaxy of stars, gas, and dust. A A galaxy with arms that curl gently, like a spiral seen from above. A galaxy that turns slowly, once every 200 million years, carrying its suns in a vast rotation. Our solar system is not fixed in space. It is part of this slow turning. The Sun, with its planets, moves around the galactic center at a speed of about 200 kilometers per second. To us, this speed is enormous. To the galaxy, it is ordinary. Every star has its own orbit. Some move in orderly paths, aligned with the flat disk of the galaxy. Others wander at angles, crossing paths, weaving patterns over millions of years. When astronomers traced the path of 3IATLAS, they found it did not align with the main flow of our galactic disk. It approached from a tilted angle, a direction not typical of local comets. This detail may seem small, but it carries weight. It suggests that the object did not come from the Oort cloud, the distant halo of icy bodies that surrounds our system. It suggests it came from outside, from another star, from another time. The galaxy is full of such fragments. Studies estimate that for every star in the Milky Way, there may be trillions of small bodies wandering between systems. They drift quietly, invisible unless they pass close to a star. Most will never be seen, most will never leave a trace, but a few, by chance, will cross paths with us. 3IATLAS was one of them. Its presence was a reminder that our solar system is not isolated, but part of this larger ocean of motion. Still, we may ask, what does this mean? On one level, it is simple. Gravity scatters bodies. Stars move. Fragments drift. Encounters happen. This is the natural language of the galaxy. But on another level, the context itself invites imagination. If countless fragments cross between systems, then every star is connected. Every world is touched by debris from elsewhere. The galaxy becomes a web of exchange, a quiet network of matter. What if that network is more than chance? What if civilizations, aware of these natural flows, learn to use them? If an advanced people lived near another star, they might have discovered the same principles of gravity and motion we study. They might have learned how to guide fragments outward. They might have used the natural rivers of the galaxy to send messages. A message hidden in a fragment would not need power. It would not need maintenance. It would only need time. From the perspective of science, this is unnecessary. Natural processes explain what we see, but from the perspective of imagination, it is possible. And possibility is enough to invite thought. A civilization older than ours might see the galaxy itself as a medium of communication. Instead of radio waves, they might use the motions of matter. Instead of signals, they might send stones. The galaxy, in this view, is not only a collection of stars, it is a vast page on which messages can be written. There is also a deeper reflection. The Milky Way has existed for more than 10 billion years. Civilizations, if they arise, may come and go in spans of thousands of years. An interstellar fragment like 3IATLAS may travel for millions of years before it arrives here. By the time it reaches us, the civilization that launched it, if one ever did, may no longer exist. The message, if there was one, may be all that remains. The messenger may outlive the sender. This invites a quiet thought about time and memory. On Earth, we build monuments, write books, carve symbols. We hope they will last beyond us. In the galaxy, fragments like 3IATLAS may serve the same role. They may be monuments, drifting forever, carrying traces of origin. To us, they appear as natural debris. To others, they may appear as signs. In both cases, they are records of the past, preserved by distance and time. Perhaps the context of the galaxy itself is the message. The stars turn slowly, but they turn together. Fragments drift outward, but they drift within that shared rotation. Over millions of years, a piece of matter can carry the memory of its origin. It can remind us that the galaxy is not silent, but filled with traces of countless histories. Still, we must remember the limits of knowledge. Our instruments see only so far. Our models reach only so back. We can trace the orbit of 3IATLAS, but we cannot trace its entire journey. We can measure its speed, but we cannot know every encounter it has had. We can imagine an origin, but we cannot prove it. The galaxy is vast, and our knowledge is small, and yet there is beauty in this smallness. The unknown is not a failure, it is an invitation. To wonder where 3IATLAS came from is to look outward, to place ourselves in a wider frame. It is to remember that the Earth is one planet among billions. It is to remember that our Sun is one star among countless others. It is to remember that the galaxy itself is turning, slowly, endlessly. So we return to the question, what if 3IATLAS was a messenger? Perhaps its message was written not on its surface, not in its light, not in its speed, but in its context. Perhaps its message was the galaxy itself, a reminder that we are part of something larger, a reminder that our system is not alone, a reminder that fragments connect us, silently, across time and space. As we rest with this thought, the galaxy continues to turn, the stars drift, the arms of the Milky Way curl slowly, like waves frozen in time. Somewhere within those arms, more fragments are moving, silent, patient, enduring. Some may come here, some may not. We cannot know which. We can only watch. We can only wonder. And in that wonder, we find calm. The galaxy is vast, older than us, larger than us, wider than we can imagine. It carries with it not only stars and planets, but also fragments like 3IATLAS. Each fragment is a reminder. Each one is a whisper. Each one is a possible message. We may never know the truth, but perhaps the truth is not as important as the reflection it inspires. Perhaps the message of 3IATLAS is not a code to be solved, but a presence to be noticed. Perhaps the galaxy itself is speaking, slowly, gently, in the only language it has, the language of motion, of distance, of time. And so we breathe, slowly, as the stars turn. We rest in the quiet thought that the universe is speaking, always, even when we hear only silence. 3IATLAS has gone, but its place in the galaxy remains. Its context is larger than us, larger than our moment, larger than our knowing. And in that vastness, we are reminded that our lives are brief, but they are part of something endless. What if 3IATLAS was not simply a wandering piece of ice and dust? What if, hidden inside its rough surface, there was something more, something shaped with intention, something crafted long ago, a machine, disguised as stone? When we look at a comet or an asteroid, we see irregular forms. We see craters, ridges, and jagged edges. We assume these shapes are the product of collisions and erosion, and in most cases, that is true. But there is another possibility, a possibility that rests not in measurement, but in imagination. A possibility that asks, could some of these shapes conceal structures? Could some of these fragments hold machines within them? The idea has been considered before. Writers, scientists, and philosophers have speculated about probes hidden inside natural bodies. The reasoning is simple. Space is vast. Travel between stars takes immense time. A machine exposed directly to space would face radiation, impacts, and erosion. But if that machine were hidden inside a protective shell of rock and ice, it could survive. The shell would act like armor. It would shield the delicate interior from harm. It would allow the message to endure. When astronomers studied 3IATLAS, they saw a faint, irregular body. Its light suggested patches, shadows, and uneven surfaces. None of this was unusual for a comet, yet the very ordinariness of its surface could be part of the disguise. A machine hidden within would not need to reveal itself. It could remain unseen. It could travel unnoticed, except for the brief moment when it crossed our sky. From a scientific perspective, the data does not require such an interpretation. The light curve, the spectrum, and the orbit can all be explained by natural causes. A fragment of rock and ice, ejected long ago, is the simplest explanation, yet the hidden machine hypothesis lingers in the imagination. It lingers because it is possible. It lingers because the disguise is effective. Consider human history. We have hidden meaning in stone before. Ancient builders carved monuments that looked like solid rock, yet within them were chambers, passages, and treasures. From the outside, they seemed like natural hills or simple structures. Only inside did the message reveal itself. If humanity has done this on Earth, is it impossible that others could do it among the stars? The idea leads to further thought. If an advanced civilization wished to send a probe across the galaxy, it might not build a shiny machine. It might not broadcast its presence with lights or signals. Instead, it might hide the machine in a fragment of rock or ice, making it appear ordinary. This would protect it during its journey. It would also allow it to pass through other systems unnoticed until the right observer looked closely. The advantage of such a method is clear. A disguised machine could survive for millions of years. It would not need to power itself continuously. It would not attract unwanted attention. It would arrive as a natural visitor, one among many, and yet, within its shell, it could hold information, technology, or even the seeds of life. For 3IATLAS, we cannot know. The data we have does not show evidence of machinery. The object was faint, observed only briefly, and is now gone. But the possibility remains in thought. It is a possibility that is almost impossible to test. And yet, the act of considering it changes how we see. Perhaps the machine is not a device in the way we imagine. Perhaps it is not wires, circuits, or metal. Perhaps the machine is the arrangement of matter itself, a crystalline structure designed to unfold under certain conditions, a pattern hidden in the ice, waiting for the warmth of a star to release it. In this view, the entire object is the machine, a slow, patient device, powered not by fuel, but by time, by light, by gravity. Still, science is careful. It does not leap to intention when chance is enough. Comets and asteroids can form in many shapes. They can contain many compounds. They can survive long journeys. The natural explanation fits. But the hidden machine idea does not compete with science. It simply extends thought beyond certainty. It lives in the space between what we know and what we wonder. This leads us to reflection. Humanity has already launched its own hidden machines. The Voyager spacecraft, the Pioneer probes, the New Horizons mission, all are small messengers, wrapped in protective shells, moving into interstellar space. To us, they are technological artifacts. To another civilization, millions of years from now, they might look like drifting debris, or they might see them as messages. In this sense, 3IATLAS reflects our own choices. We have already placed machines in stone-like forms. We have already sent them outward. We have already hidden meaning in matter. The difference is only one of scale. Our probes have traveled for decades. An interstellar fragment travels for millions of years. Perhaps the hidden machine, if it exists, does not need to be discovered quickly. Perhaps it is designed to wait. Time, in the galaxy, is abundant. A message does not need to be urgent. It can be patient. It can wait for the right moment, the right observer, the right level of awareness. The machine does not call attention to itself. It allows us to choose whether to notice. What if 3IATLAS was such a messenger? What if its surface, irregular and natural, concealed something older than our civilization? What if the faint light we measured was only the surface, and the true message was inside? We cannot answer these questions with certainty. Our instruments did not see inside. Our time was too short. The object is gone. Yet the thought remains, and the thought itself is a kind of message. A message that invites reflection. A message that asks us to wonder what lies beyond what we can measure. In the end, 3IATLAS is remembered as a faint interstellar comet. Its chemistry, its orbit, its speed, all match natural explanations. But in the imagination, it is also something else. It is a stone that may hide a machine. It is a fragment that may carry a message. It is a visitor that reminds us of the thin line between chance and choice. As we let this thought rest, we return to the night sky. We see stars above, distant and silent. We see darkness between them. We imagine countless fragments drifting, each one a possible messenger. Some are natural, some may be more. We cannot know which. But in the act of wondering, we join the conversation. What if 3IATLAS was a messenger? Perhaps its silence was deliberate. Perhaps its shape was chosen. Perhaps inside its stone, a machine waits still, drifting beyond the reach of our instruments. Perhaps its message is not for us, but for someone else. Or perhaps its only message is that we are not alone, and that the universe is larger than our certainty. And so, as the galaxy turns slowly, we pause, we breathe, we imagine, we accept that some questions may remain unanswered, and in that acceptance, we find calm. The fragment moves on, the stars continue their slow dance, and we remain here, listening to whispers carried not in sound, but in stone. What if 3IATLAS was a messenger? Not in the sense of carrying machines, not in the sense of broadcasting signals, but in the quietest sense of all as a symbol. To think about this possibility, we must first pause and ask, what do we mean when we speak of a message? A message is usually thought of as a transmission of information. It has a sender, a receiver, and a code that links them. Words, numbers, patterns of sound or light, all of these can serve as carriers of meaning. On Earth, we are used to clear signals. We write letters, we speak sentences, we send radio waves. Each message is designed to be understood, but the universe is not always so direct. It does not send words. It does not write in alphabets we can read. It presents us with patterns, orbits, shapes, spectra, and silences. The question is whether these patterns are only accidents, or whether they can also be messages. Philosophers have long discussed the difference between intention and interpretation. A stone carved into a figure is intentional. A stone shaped by erosion is accidental. Yet, when we look at a cliff or a cloud, we sometimes see faces, animals, or symbols. Our minds supply meaning, even when none was placed there. The universe is full of such illusions. Stars form patterns we call constellations, though the stars themselves are scattered across vast distances. We join them in our minds, and the patterns become signs. In the case of 3IATLAS, its shape and motion were unusual. Its light rose and fell in ways that were hard to explain. Some said it was elongated. Others said it was flat. The data allowed multiple interpretations. No single model fit perfectly. This uncertainty left space for speculation. Was it natural? Was it intentional? Was it both? Here, the philosophy of messages becomes gentle but deep. If an intelligent civilization wished to send a message, how would they do it? Would they use a method we already know, like radio? Or would they choose a method that is more enduring, more subtle, more universal? Light curves, chemical ratios, orbital paths, all of these can be read as signals. All can be interpreted as patterns, but whether they are intended as messages is something we cannot confirm. Perhaps the message is not in the data itself, but in the act of looking. The moment astronomers turned their instruments toward 3IATLAS, they entered into a conversation with the universe. They asked questions, they measured carefully, they debated possible shapes and origins, they wondered about natural and artificial causes. This act of wondering is itself a response to a kind of message, even if the message is silence. Still, the thought lingers. If there were an ancient intelligence, patient enough to think in spans of millions of years, it might not rely on words. It might not expect its message to be decoded quickly. It might not even care whether the message was understood. The message could be the object itself. The presence of a fragment drifting across a foreign sky could be the signal, a silent sign that says, "We were here, we existed, we moved matter across the galaxy." In this way, the philosophy of messages expands. A message need not be clear, it need not be intentional. It can be ambiguous, uncertain, and incomplete. It can be a pattern that invites reflection rather than delivers information. In human life, we often treat meaning as something to decode, but sometimes meaning is created in the act of interpretation. Sometimes the message is not in what is said, but in what is felt. This is why 3IATLAS lingers in memory. It did not speak, it did not signal, it did not reveal itself, and yet, its presence caused us to ask questions. It caused us to wonder about origins, about intelligence, about purpose. In this way, it functioned as a message, even if no one sent it. The message was not in its body, but in our response. Science continues to measure and analyze. Astronomers publish careful papers full of data and models. They emphasize what is known, the orbit, the speed, the chemistry. They acknowledge what is not known, the exact shape, the precise origin, the full history. Their work is cautious, grounded in evidence. It avoids leaps of imagination. And yet, around the edges of that work, questions remain. Those questions are part of the story. Perhaps this is the quiet role of interstellar visitors. They are not only objects to be measured, they are also invitations to wonder. They remind us that the universe is larger than our instruments, larger than our certainty, larger than our definitions of messages and meanings. They remind us that the line between natural and intentional may be thinner than we think. They remind us that meaning can arise even in silence. In philosophy, there is a thought that the act of interpretation creates its own reality. When we see a comet and call it an omen, we shape our choices around it. When we see an interstellar object and call it a messenger, we shape our thoughts around it. The object may not change, but we do. The message, then, is not what is sent, but what is received. What if 3IATLAS was a messenger? Perhaps it carried no signal, no machine, no clear code. Perhaps it carried only ambiguity. Perhaps its message was to remind us that not all patterns are meant to be solved, not all appearances are meant to be explained. Perhaps its message was to remind us that meaning is something we create, quietly, in our own minds. This does not erase the science. The data still matters, the light curve still matters, the orbit still matters, but alongside the science, there is reflection. Alongside the measurements, there is wonder. Alongside the facts, there is philosophy. And sometimes, when we seek sleep, it is this gentle balance that calms the mind. As we close this part of the journey, we return to the image of 3IATLAS drifting through space, a fragment of rock and ice, a faint light in the sky, a shape that resists easy description, a body that came once and is now gone. To science, it is natural. To imagination, it is a messenger. To philosophy, it is a question that may never be answered. Perhaps that is the final lesson of the philosophy of messages, that the universe speaks in many ways, that sometimes it speaks through words, sometimes through numbers, sometimes through silence, sometimes through shapes, and sometimes it does not speak at all. Yet in our effort to listen, in our willingness to wonder, we find meaning. And so, we rest with this thought. The stars shine quietly above us. The galaxy turns slowly. 3IATLAS is gone, but its question remains. What if it was a messenger? What if the message was not something to decode, but something to feel? A reminder of connection, a reminder of mystery, a reminder that the act of wondering is itself a kind of dialogue. What if 3IATLAS was a messenger, but our instruments were not yet ready to hear what it carried? When astronomers search the sky, they do not use their eyes alone. They rely on telescopes, detectors, and receivers. These instruments extend human senses, making the invisible visible. Light beyond what we can see, radio waves beyond what we can hear, particles beyond what we can touch. All of these become knowable through machines. Yet every instrument has limits. Every detector sees only a narrow range. Every measurement is partial. Modern astronomy is built on light. The telescopes we use collect photons, the tiny packets of energy that travel across space. Some instruments see visible light, the same light our eyes detect. Others see infrared, ultraviolet, X-rays, or radio waves. Each window reveals something different. Infrared light shows us heat. X-rays reveal energetic events. Radio waves trace magnetic fields. By combining them, astronomers form a more complete picture. But there are always gaps. Some signals are too faint. Some wavelengths are blocked by Earth's atmosphere. Some patterns fall outside what our detectors can capture. When 3IATLAS was discovered, telescopes turned toward it as quickly as possible. Observations were made in visible light. Some radio telescopes listened for artificial signals. Some infrared instruments searched for heat. The data came back, but it was faint, incomplete, and difficult to interpret. The object was already fading. Its speed carried it away faster than our instruments could follow. The scientific conclusion was cautious. The object looked like a comet. Its light suggested ice and dust. Its orbit confirmed it was interstellar. No unusual signals were detected. From a scientific point of view, the simplest explanation was that it was natural debris, but the story does not end there. The gaps in our instruments leave room for speculation. Consider the scale of the universe. Light travels fast, yet distances are vast. A signal broadcast from another star may be drowned in noise by the time it reaches us. A faint emission from a distant fragment may fall below our detection threshold. A structure hidden within a rock may be invisible to our telescopes. The absence of evidence is not evidence of absence. The silence of our instruments may reflect only their limits. This raises a gentle question. If there were a message in 3IATLAS, would we even know? If the message was written in a form outside our detection, would it pass by us unnoticed? We assume that other intelligences would use the signals we expect. We build instruments to match our expectations. But what if their methods are different? What if the universe carries messages in forms we cannot yet perceive? Science itself accepts this possibility. Each generation builds better tools, and each generation sees farther. Telescopes of the past could not have detected 3IATLAS at all. Only with new surveys, more sensitive instruments, and careful observation did we notice it. In the future, even more sensitive instruments may show details we missed. Perhaps we will learn more about this fragment, or about others yet to come. Perhaps we will find patterns we cannot now see. Still, the act of measurement is shaped by limitation. Detectors saturate. Noise overwhelms signal. Data is incomplete. Scientists are cautious, careful not to claim more than the evidence allows. This restraint is necessary. It keeps science grounded. Yet, beyond the caution, imagination continues. The limits of our instruments remind us that we do not see everything. They remind us that the universe is larger than our reach. There is a parallel in human experience. Our senses are limited. We hear only certain frequencies. We see only certain wavelengths. Yet we know that beyond our perception lies more. Infrared light warms us, though we cannot see it. Ultraviolet light burns us, though we may not notice. Sound travels farther than we can hear. In every direction, there are signals we cannot perceive. Our instruments extend us, but they, too, are partial. What if 3IATLAS carried a message in one of those unseen forms? What if its surface contained patterns visible only in wavelengths we did not measure? What if its structure vibrated in ways our instruments could not detect? What if its message was there, but beyond our range? We may never know. The object has passed, and our instruments recorded what they could. The rest is lost, but the loss itself is instructive. It reminds us that knowledge is always partial. It reminds us that we live within limits. It invites us to wonder what lies beyond them. Philosophically, this raises another question. Is a message still a message if it cannot be read? If an object carries meaning that we cannot perceive, does that meaning exist for us? Or is it only potential, waiting for a different time, a different observer, a different technology? Perhaps messages exist all around us, but we do not yet have the instruments to hear them. Perhaps the universe is already speaking, in forms beyond our current reach. In human history, this has happened before. There were sounds we could not hear, until we built radios. There were rays we could not see, until we built detectors. Each new instrument revealed something that was always there. Perhaps the same is true of interstellar messengers. Perhaps 3IATLAS carried signals we could not yet detect. Perhaps in the future, with new instruments, we will look back at the data and see patterns we once missed. Still, even if we never find such patterns, the object has already spoken to us in another way. It has reminded us of humility. It has shown us that our instruments are limited, that our senses are incomplete. It has reminded us that the universe is wider than our measurements, that the unknown remains vast. What if 3IATLAS was a messenger? Perhaps its message was not in the data we captured, but in the data we missed. Perhaps its message was that we are not yet ready. Perhaps it was sent to show us the distance between what exists and what we can see. As we rest with this thought, we can imagine the quiet persistence of its journey. Moving outward, beyond our reach, it carries on, untouched by our limitations. It does not slow, it does not stop, it does not wait for us. And yet, for a moment, it gave us the chance to wonder. The universe is not silent, it is only vast. Its signals are many, spread across wavelengths we cannot yet perceive. Our instruments grow more sensitive with time, but they will always be partial. The gaps remain, the unknown remains. And in those gaps, imagination takes root. So we return once more to the question, what if 3IATLAS was a messenger? If so, perhaps it was not ignored. Perhaps its silence was not failure. Perhaps its message was to remind us of our own limits and of the endless work of listening, a message written in what we could not detect, a message reminding us that knowledge is always incomplete. And as we sit with this thought, the night stretches wide, the stars shine softly. The instruments listen, but the silence is steady. We breathe, slowly, gently, aware that what we cannot measure may still exist. The unknown surrounds us, and in its quiet persistence, it becomes a calm companion. What if 3IATLAS was not alone? What if its journey across our sky was not a singular event, but part of a quiet sequence? The universe may not speak in single words. It may speak in echoes. In the year 2017, astronomers first witnessed something extraordinary. A small, elongated object passed through our solar system. They called it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. It was the first interstellar object ever identified. Its path was hyperbolic. Its speed was too high for the sun to hold it. It came from elsewhere. It passed by. It was gone. At the time, Oumuamua seemed unique. Astronomers wondered if such an encounter might never happen again in their lifetimes. They thought of it as a rare event, a singular glimpse of the wider galaxy. Yet only 2 years later, in 2019, another object appeared. It was Comet Borisov. Unlike Oumuamua, it displayed a clear tail of gas and dust. It looked like a comet, yet its orbit was hyperbolic, proving it too had come from beyond. And then, in 2023, came 3IATLAS, a third visitor. Fainter, less dramatic, but unmistakably interstellar. 3 visitors in just a few short years. From a scientific perspective, this was significant. It suggested that interstellar objects are more common than once thought. Perhaps they pass through our solar system regularly, unnoticed until we had the tools to see them. Still, a question arises. If these events are so common, why did we not see them before? The answer lies partly in our instruments. Telescopes in the past were not as sensitive. Surveys were not as wide. Oumuamua, Borisov, and Atlas were detected because our tools had improved. Their echoes may have been present all along. We simply could not hear them. Yet the repetition invites another kind of thought. 3 visitors in such a short span, one elongated, one cometary, one faint. What if these are not separate accidents? What if they are connected? What if they are parts of a larger pattern, each a syllable in a cosmic sentence? Science does not require this. It explains the discoveries in terms of improved detection. The objects were always there. We are only now able to see them. This is reasonable. It is grounded. It is cautious. And yet, imagination continues. If these are echoes, then perhaps the universe is speaking to us. Not in words, but in appearances. Not in language, but in repetition. Consider the nature of echoes on Earth. A sound is made, it bounces, it returns. Each echo is fainter, more distant, but still connected to the first. An echo is not new sound. It is the same sound, carried farther. In the same way, each interstellar visitor may be an echo of earlier events. A collision, an ejection, a scattering, or perhaps, if we imagine more boldly, each visitor is an echo of a deliberate act. A series of messengers, launched across time, passing one after another, to be noticed by those who look upward. The echoes of Oumuamua remind us of patterns. In science, patterns are important. They tell us when something is not random. They suggest laws, processes, regularities. When we saw 3 interstellar visitors in a short span, the pattern suggested abundance. It suggested that interstellar debris is not rare, but common. This was a quiet revelation. The galaxy is not empty. It is filled with fragments moving steadily, waiting to be seen. But patterns also invite reflection. Humans have always found meaning in repetition. The rising of the sun each day, the cycles of the moon, the return of the seasons. Repetition creates rhythm. Rhythm creates expectation. Expectation creates meaning. The repeated arrival of interstellar visitors feels like such a rhythm. It suggests that there will be more. It suggests that the universe will continue to send us echoes. Still, we cannot conclude intention. We cannot say these visitors were designed. We can only note the pattern. We can only wonder whether it is natural or deliberate. The line between chance and design is thin. Both can produce repetition. Both can create echoes. The difference lies not in the pattern itself, but in the purpose behind it. And that purpose is something we may never know. Perhaps the echoes are natural. Perhaps they are the result of countless collisions, countless ejections, countless fragments drifting across the galaxy. If so, then the message is that the universe is rich with material exchange. Our system is not isolated, it is part of a larger flow. The echoes are natural, but they still remind us of connection. Perhaps, instead, the echoes are intentional. Perhaps an ancient civilization has chosen to send fragments across the galaxy, one after another, like syllables in a long, slow message. Each fragment appears once, then disappears, leaving behind a trace of its passage. If this were true, then 3IATLAS would not only be a fragment, it would be part of a communication, a gentle signal, spread across ages. There is another possibility still. Perhaps the repetition lies not in the objects themselves, but in our noticing of them. Perhaps interstellar visitors have always come, but we are only now able to see. Perhaps the true pattern is in us. Our instruments have grown. Our awareness has expanded. Our curiosity has deepened. The echoes we hear may be echoes of our own readiness. This thought is soft, but steady. It reminds us that the universe is not separate from us. It reminds us that meaning arises not only from what happens, but from when we are able to see it. The echo may not come from the object. It may come from our recognition. The pattern may be written not in the stars, but in our attention. As 3IATLAS fades into the dark, we are left with echoes. Echoes of Oumuamua, echoes of Borisov, echoes of countless other fragments, unseen but present. Each one is a whisper. Each one is a reminder. Each one is part of a rhythm that stretches beyond us. What if 3IATLAS was a messenger? Perhaps it was not the first. Perhaps it was not the last. Perhaps its message is not complete alone, but only in relation to others. Perhaps the universe speaks in echoes, across time and space, across stars and systems. Perhaps we have only begun to hear the first syllables. We may never know if this is true. The objects we have seen may be natural. The pattern may be coincidence. But the thought itself carries weight. The thought itself is a kind of message. A message that invites us to listen more carefully, to measure more patiently, to wonder more deeply. As the galaxy turns slowly, more fragments will come. Some will be bright, some faint, some unusual, some familiar. Each will be an echo. Each will be a reminder. Each will be a chance to listen again. And so, as we rest with this thought, we return to calmness. The night is wide. The stars shine softly. The echoes of distant events drift through space, faint but persistent. We listen, even when the signals are weak. We wonder, even when the patterns are uncertain. And in that wondering, in that listening, we find stillness. What if 3IATLAS was only the beginning? What if the quiet fragment that slipped past us was not the last visitor, but one of many? To imagine this, we must look not only at what has been seen, but also at what we may yet learn to see. Astronomy is a science of patience. It advances slowly, one observation at a time. For centuries, humans looked at the night sky with the naked eye. They drew maps of stars. They noted the movements of planets. They recorded comets as sudden streaks of light. Then, with the invention of the telescope, the sky opened wider. Details appeared. Moons were seen around Jupiter. Rings were revealed around Saturn. Nebulae were drawn with care. Each new instrument brought new vision. Today, telescopes are larger, more sensitive, and more precise than ever before. They sit on mountaintops, above much of the atmosphere. They orbit in space, far from the distortion of air. They collect light across the spectrum, from radio waves to gamma rays. Yet even with all this, 3IATLAS was barely visible. It was faint, small, and fast. It passed quickly. We saw only a glimpse. This reveals something important. Our instruments are still limited. They see much more than our eyes, yet they do not see everything. A fragment like 3IATLAS may pass unnoticed unless we are watching in just the right way, at just the right time. For every one we detect, there may be thousands we miss. The future of watching, then, depends on building tools that can see more and see farther. One of the most significant new tools is the Vera C. Rubin Observatory. Located in Chile, it will survey the entire southern sky again and again, night after night. Its wide-field camera will capture vast images, covering more area in a single snapshot than any telescope before it. By comparing images over time, astronomers will notice faint objects moving against the background of stars. Interstellar visitors, once rare in our awareness, may become common in our observations. Other telescopes are being prepared in space. The James Webb Space Telescope, launched in the year 2021, sees the universe in infrared. It can detect the faint glow of distant galaxies, the warm signatures of planets, and the hidden light of cold objects. If another interstellar body like 3IATLAS appears, Webb may be able to study its chemistry in more detail, capturing the faint signals that were missed before. There are also plans for future missions dedicated to interstellar objects. Some proposals suggest spacecraft that could launch quickly, intercepting a visitor as it passes through the solar system. Such missions would be difficult. The speeds are high, the opportunities are brief, but with careful planning and with readiness, it may be possible. One day, a spacecraft may fly alongside an interstellar fragment, taking images, measuring its surface, sampling its material. One day, we may see directly what is hidden now. Yet even as we imagine these possibilities, we must pause. We must remember the quiet rhythm of the universe. New instruments will show us more, but they will also remind us of more that we cannot see. For every object we detect, countless others will still pass unnoticed. For every detail we capture, other details will remain hidden. The future of watching is not the end of mystery, it is the continuation of it. This raises another gentle thought. Watching is not only about gathering data, it is also about attention. To watch is to care. To turn our instruments toward the sky is to admit that we wish to see. Each new telescope, each new survey, is an expression of curiosity. It is an acknowledgement of our desire to know. The act of building instruments is itself a message from us to the universe that says, "We are listening." Perhaps this too is part of the dialogue. If the universe carries messages in fragments like 3IATLAS, then our instruments are the ears that might hear them. As those instruments grow, the dialogue becomes clearer. The universe speaks, in light and shadow, in orbit and speed, in silence and in chemistry. We respond with telescopes, with detectors, with careful measurement. The exchange is slow, it is quiet, it is patient. Still, the possibility of connection lingers. What if, with new instruments, we begin to see patterns that were hidden before? What if the faint brightness variations we once dismissed as noise reveal themselves to be structured? What if the chemistry of a future interstellar visitor shows compounds we did not expect? What if the universe has always been speaking, and only now are we learning to listen? Science will approach these discoveries carefully. Data will be measured, compared, tested, and debated. Conclusions will be cautious, but outside of science, imagination will continue to wander. People will ask again, are these visitors natural? Are they designed? Are they messages? Each new discovery will invite reflection. Each new instrument will expand not only our knowledge, but also our wonder. There is also a quiet paradox. The better our instruments become, the more we realize how small we are. Each new telescope reveals more stars, more galaxies, more distance. Each new detector reveals signals we did not know existed. Instead of closing mysteries, they open new ones. The universe becomes larger with every step. The horizon moves farther away. Perhaps this is the gentle message of the future of watching, that there will always be more to see, that our instruments, no matter how powerful, will never capture everything, that the act of watching is endless. In this way, watching is not about reaching an end, but about continuing the process. Each new telescope is another step in an unending journey. As 3IATLAS drifts away, it leaves us with this reminder. We saw it only because our instruments were ready, just enough, at just the right time. We may have missed countless others. We may see countless more in the future. The act of watching itself is part of the message. It is part of the dialogue between us and the universe. And so, once more, we return to the question, what if 3I Atlas was a messenger. Perhaps its message was not in its shape, or its chemistry, or its silence. Perhaps its message was simply this: keep watching. Build better instruments. Look deeper. Listen longer. Wait with patience. The universe is vast, and it will not hurry. As we rest with this thought, the night stretches out quietly. Telescopes turn slowly across the sky. Cameras open and close, recording light that has traveled for ages. The data gathers, patiently, steadily. We do not know what it will reveal. We may never know. Yet the act of watching is its own reward. It slows the mind. It opens the heart. It reminds us that to be human is to wonder and to wait. What if silence itself was the message? What if 3IATLAS, in its brief crossing of our sky, chose not to speak in light or radio waves, not to reveal machinery or code, but simply to remain quiet? At first, silence seems like absence. It feels like nothing. We turn our instruments toward the sky, and when nothing unusual returns, we call it empty. But silence, in the long history of human thought, has never truly been empty. It has always carried meaning. When our ancestors looked at the night sky, they saw silence, yet they filled it with stories. Constellations became myths. Gaps between stars became pathways of gods. Darkness itself became a canvas for imagination. Silence, in this sense, was not the lack of message, but the very space in which meaning could grow. To be silent is not to be absent. It is to leave room for interpretation. Astronomers listened carefully for 3IATLAS. They tuned radio telescopes. They scanned across frequencies. They hoped for a signal. None came. The data matched what was expected of a comet. Faint light, gentle fading, no artificial transmission. Science concluded carefully that it was natural. The instruments heard only silence. Yet outside the cautious voice of science, imagination wondered. What if silence was deliberate? What if an intelligence chose not to broadcast, not to announce itself, but to remain quiet? In human terms, silence can mean respect. It can mean patience. It can mean trust. A moment of silence is often a gesture of remembrance or of reverence. It is not empty. It is full. Perhaps, in the same way, an interstellar messenger might choose silence as its form. If so, then 3IATLAS may have carried a message without words. Its message may have been notice. Its message may have been wonder. Its message may have been, in silence you will find meaning. The absence of a signal forced us to look more closely. It forced us to question our assumptions. It forced us to wonder whether our instruments were enough, whether our understanding was complete, whether our expectations were too narrow. There is a parallel in human experience. In conversation, silence can be awkward. It can feel heavy, uncomfortable, but it can also be profound. A pause can hold more weight than speech. A moment of stillness can carry more meaning than words. In music, silence is as important as sound. The rests between notes shape the melody. Without silence, music would be only noise. The same may be true of the universe. Without silence, its patterns would not stand out. When 3IATLAS passed through our sky, it was silent. Yet the silence was not empty. It was filled with the faint glow of reflected sunlight. It was filled with the rhythm of its turning. It was filled with the questions it left behind. Why now? Why here? Why in our lifetime, after so many centuries of waiting? The silence did not answer these questions, but the silence made us ask them. That act of asking may be the message itself. From a scientific perspective, silence is data. It tells us that no artificial signals were detected. It tells us that the object behaved as expected for a comet. It tells us that within the limits of our instruments, nothing unusual was found. These are facts. They are clear, they are precise, and they are cautious. Yet beyond these facts, the silence resonates. It resonates because it touches something older than science. It touches the human tendency to wonder at what is absent. In philosophy, silence has been treated as paradox. It is the presence of absence. It is the sound of nothing. It is the space in which thought can arise. Mystics have spoken of silence as a path to truth. Poets have described it as language beyond words. Philosophers have argued that silence is itself a form of communication, one that depends not on the sender, but on the listener. In this light, the silence of 3IATLAS becomes a kind of dialogue, not because it spoke, but because we listened. Perhaps this is the most universal form of message. Words require shared language. Signals require shared codes. Machines require shared knowledge. But silence requires none of these. Silence is universal. It is the same across cultures. It is the same across species. It is the same across galaxies. A silent visitor passing through may be understood not by what it says, but by the space it leaves. Still, we may wonder, is silence enough? If a civilization wished to communicate, would it not speak clearly? Would it not broadcast? Would it not design a signal that could not be missed? Science suggests that 3IATLAS was natural. Its silence was expected. Its faintness was ordinary. But imagination suggests another layer. Silence may be chosen, not because it hides, but because it reveals. It may say, meaning is not given, it is found. In this way, silence is not emptiness. It is possibility. It allows the listener to participate. It allows us to create meaning. It invites us to reflect. The silence of 3IATLAS was not an absence of message. It was a message about absence. It reminded us that the universe does not always speak in ways we expect. It reminded us that not everything is given directly. It reminded us that sometimes we must create meaning ourselves. In human life, silence plays a similar role. In moments of grief, we fall silent. In moments of awe, we fall silent. In moments of peace, we fall silent. Silence is not nothing. Silence is presence without noise. Silence is attention without words. To sit in silence is to feel time move differently. It is to feel space expand. It is to rest. Perhaps 3IATLAS carried such a message. Perhaps it said, in silence, you will learn. In silence, you will listen. In silence, you will remember your place in the vastness. The object drifted past us quietly. It did not call for attention. It did not demand understanding. It only passed. Yet in that passing, it left behind reflection. Science will continue to search. Instruments will continue to listen. Most of the time, they will hear silence. Most of the time, they will find nothing unusual. But perhaps that is the point. Perhaps the silence itself is what endures. Perhaps the silence itself is the message. And so, once again, we return to the question, what if 3IATLAS was a messenger? If so, perhaps its message was not hidden in machinery or light or chemistry. Perhaps its message was silence. A silence that invites us to listen. A silence that reminds us of humility. A silence that allows wonder to grow. As we rest with this thought, the night stretches wide. The stars shine faintly. The sky is quiet. The silence continues, steady and calm. We listen, not for what is said, but for what is not said. We listen, not for answers, but for presence. And in that listening, in that silence, we find peace. What if 3IATLAS was a messenger, and its message was carried not in words, not in light, not in silence alone, but in the very length of its journey? The path of 3IATLAS stretched back beyond our reach. Astronomers, tracing its orbit, could say with care that it did not belong to the sun. They could say it came from elsewhere. They could calculate its speed, and from that speed, infer its freedom. But they could not say when it had begun its journey. They could not say how many millions of years had passed since it was ejected. The long journey remains hidden, veiled by time. In human terms, even thousands of years feel immense. Our civilizations rise and fall within centuries. Our lifetimes are measured in decades. Against this scale, 1,000,000 years is difficult to imagine. Yet in cosmic terms, 1,000,000 years is brief. Stars live for billions of years. Galaxies rotate slowly, taking 200 million years to complete a single turn. An object like 3IATLAS could have traveled not for 1,000,000 years, but for tens, or hundreds, or more. During that journey, it may have passed near many stars. Each passage would have been quiet. Each crossing would have left no trace, except perhaps a faint change in its orbit, a small tug of gravity. Over time, those tugs added together, shaping its path. The long journey was not smooth. It was interrupted, bent, adjusted, yet it continued. It endured. This endurance is part of its message. To drift for millions of years is to persist beyond storms, beyond collisions, beyond the collapse of stars. To continue without destination, to move endlessly forward, is to embody patience. In human life, we are often hurried. We measure progress by speed, by growth, by results. But in the galaxy, progress is measured differently. It is measured in survival. It is measured in persistence. It is measured in the quiet passing of time. The long journey also carries memory. The surface of 3IATLAS records what it has endured. Cosmic rays leave marks. Dust grains carve small craters. Ice sublimates, leaving scars. These traces are not written in words, but they are still records. They are a history written in matter itself. A history that spans ages. A history we can only glimpse faintly. Through telescopes, through data, through models. From a scientific perspective, this history is precious. It offers clues to the conditions of other star systems. It offers evidence that the building blocks of our world are shared across the galaxy. It suggests that planetary systems form, collide, and scatter fragments often. It suggests that interstellar visitors are common. It suggests that the long journey is not rare, but ordinary. Yet from a reflective perspective, the long journey carries other meanings. It reminds us of endurance. It reminds us of patience. It reminds us of humility. If a fragment can drift for millions of years, then our own lives are brief moments. If a fragment can survive collisions, radiation, and distance, then survival itself is a form of message. The message may be, continue. The message may be, endure. The message may be, move forward, even when the path is long. There is a parallel in human experience. Journeys are not always swift. Sometimes they take years. Sometimes they take lifetimes. Sometimes they are never completed. Yet the act of continuing, the act of moving forward step by step, carries meaning. A long journey does not need to end to have value. The movement itself is meaningful. Perhaps 3IATLAS, in its long journey, reminds us of this. Perhaps its message is not about where it came from, nor about where it is going, but about the act of traveling itself. To drift for ages, to endure in silence, to continue forward without a rival, this is its message. A message of patience, a message of persistence, a message of calm. Still, we may wonder, if 3IATLAS was guided, then its long journey was not random. It was chosen, it was planned, it was designed. An advanced intelligence might have set it on its course, knowing it would take millions of years to arrive. They might have trusted that, one day, someone would notice. The long journey, then, would be part of the message. A message that says, "We thought of you long ago. We prepared this fragment, not for ourselves, but for you." We cannot know if this is true. Science cannot confirm intention. It can only measure motion, speed, light, and chemistry. It can only say what is consistent with natural causes. The simplest explanation is that 3IATLAS was a natural fragment. That is the grounded conclusion. Yet the possibility of intention lingers. The long journey leaves room for wonder. Perhaps the message of 3IATLAS is not about communication in the ordinary sense. Perhaps it is about perspective. To know that an object has traveled for millions of years across the galaxy only to pass briefly before our eyes is to feel the depth of time. It is to feel the scale of the universe. It is to remember that our lives, brief as they are part of something larger. In the end, 3IATLAS has gone. Its long journey continues, outward, into the dark. We will not see it again. It will drift on, perhaps for another million years, perhaps for longer than the Earth itself will exist. We cannot follow. We cannot know its full path. We can only imagine. And so, once more, we return to the question, what if 3IATLAS was a messenger? Perhaps its message was not in its light, or its shape, or its silence, but in its journey. A journey that stretches across time, across distance, across the galaxy itself. A journey that reminds us that patience is also a form of endurance. A journey that tells us, softly, that meaning can survive even when we cannot. As we rest with this thought, we imagine the fragment moving farther away into the quiet dark. We imagine its path stretching endlessly, a line across the galaxy. We imagine the silence around it, the patience within it, the persistence that carries it forward. We breathe slowly, we feel the rhythm of time. We remember that we, too, are travelers. Our journeys may be shorter, our paths may be briefer, but we, too, move forward, carried by time, carried by the same galaxy, carried by the same silence. What if 3IATLAS was not only a messenger from the stars, but also a mirror? A mirror does not create an image of its own. It only reflects. It shows us what is already there. Sometimes, when we gaze at the universe, we are not only learning about distant objects, we are also learning about ourselves. When astronomers pointed their telescopes toward 3IATLAS, they hoped to capture data. They sought numbers, spectra, trajectories, shapes. They sought evidence. What they received was faint light, ambiguous curves, uncertain chemistry, and silence. The object revealed little about itself. Yet in our response, it revealed something about us. It revealed our curiosity, our patience, our desire to understand, and our willingness to imagine. In this way, 3IATLAS became a mirror. It reflected our own longing, it reflected our questions, it reflected the limits of our instruments and the persistence of our search. The object itself may have been silent, but the conversation it sparked among us was not. Scientists debated, writers speculated, philosophers reflected. Each response was shaped not only by the data, but by human imagination. The object became a surface upon which we projected meaning. This act of projection is familiar. Throughout history, humans have looked to the sky for guidance. They have seen patterns in stars, messages in comets, omens in eclipses. These patterns may not have been intended, but they carried meaning. They shaped choices, inspired stories, guided rituals. In this sense, the sky has always been a mirror, reflecting back what we bring to it. Still, the mirror does more than reflect. It also invites. When we see ourselves in the sky, we are reminded of our connection to it. We are reminded that we are part of the same universe. We are reminded that the atoms in our bodies were once in stars. We are reminded that our own world is a fragment, moving in orbit, shining briefly in time. The mirror shows us not only who we are, but also where we belong. From a scientific perspective, 3IATLAS is still a natural object. Its orbit is consistent with scattering. Its chemistry matches that of comets. Its silence matches expectation. The simplest explanation remains that it is a fragment of rock and ice, drifting by chance. Science is cautious. Science values evidence. Science does not leap to speculation. Yet beyond science, reflection continues. The mirror invites us to ask gentle questions. What if our search for messages in the sky is also a search for ourselves? What if the patterns we see in 3IATLAS, its orbit, its speed, its shape, its silence, are also patterns within us? What if the messenger reflects the listener as much as the sender? Perhaps this is the quiet truth. Perhaps the universe does not speak to us directly. Perhaps it does not send messages in words or signals. Perhaps it only reflects. Perhaps it shows us fragments, and in those fragments, we see ourselves. We see our curiosity. We see our longing. We see our humility. The messenger becomes a mirror. There is a gentle parallel in human life. When we look into the eyes of another person, we see not only them, but also ourselves. Their gaze reflects our own presence. Their silence reflects our own thoughts. Their expression shapes our response. In this way, every encounter becomes a mirror. Every meeting becomes a reflection. 3IATLAS, drifting across our sky, may have served the same role. It reflected not light alone, but also our awareness. The long journey of 3IATLAS reminds us of endurance. Its silence reminds us of humility. Its shape reminds us of ambiguity. Its orbit reminds us of transience. Taken together, these qualities mirror our own existence. We endure. For a time, we are silent, in the vastness of space. We are ambiguous in our interpretations. We are transient in the scale of the cosmos. The messenger reflects us back to ourselves. Still, we may ask, is this reflection itself the message? If 3IATLAS was a messenger, perhaps it was not sent to deliver new information. Perhaps it was sent to remind us of what we already know, but often forget: that we are small, that we are fleeting, that we are connected to the universe we observe, that our act of watching is part of a larger rhythm. In philosophy, mirrors have long been symbols of reflection, both literal and inward. To look into a mirror is to see oneself, but also to see the act of seeing. It is to realize that perception is shaped by perspective. In the same way, when we looked at 3IATLAS, we may have seen less of the object itself and more of our own curiosity. The faint light did not tell us who sent it, but our response, the questions we asked, the debates we had, the stories we imagined, revealed something about us. This duality is gentle. It does not demand an answer. It does not insist on one interpretation. It leaves space for both science and imagination. Science says, this was a natural object. Imagination asks, what if it was a messenger? Philosophy reflects, perhaps the message is the act of wondering itself. And so, as we look toward the future, the mirror remains. More visitors will come. More fragments will cross our sky. Some will be bright, some faint, some strange, some ordinary. Each one will be a chance to measure, to listen, to imagine. Each one will be a chance to see the universe and to see ourselves within it. What if 3IATLAS was a messenger? Perhaps it was not meant to speak of others at all. Perhaps it was meant to speak of us. Perhaps its message was to hold up a mirror, to show us our own curiosity, our own humility, our own longing. Perhaps its silence reflected our search for meaning. Perhaps its transience reflected our own. In the end, we may never know. The object is gone. The data is incomplete. The message, if there was one, remains uncertain. Yet the reflection remains. The mirror remains. The wonder remains. As the night sky stretches above us, calm and still, we are reminded once more of our place. We are travelers, like 3IATLAS. We are fragments of matter, drifting in orbit, moving through time. We look outward, but we also look inward. The mirror of the universe shows us both. And so, as we close this part of the journey, we pause. We breathe slowly. We let the thoughts settle. What if 3IATLAS was a messenger? Perhaps it carried no words. Perhaps it carried only a mirror that reflects not its own image, but ours. A mirror that reminds us that in seeking messages from the stars, we also uncover messages within ourselves. A mirror that invites us to rest, to reflect, and to listen.